everyone, and welcome to this month's Python Exchange. My name is Cameron Riddell, and I will serve as your host for today. Today, we are excited to be joined by Philipp Rüdiger. Philipp is a principal software engineer at Anaconda and the team lead for HoloViz, where he's been at the center of some of the most important development in Python's visualization ecosystem. If you've ever used a tool like HoloViews, Bokeh, Datashader, Panel, or hvPlot, there's a good chance you've already benefited from his work. His focus has been on making interactive visualizations and data exploration feel like a natural extension of the way we already work in Python, not something that's bolted on afterwards, but something that's a part of the analysis from the very beginning. Philip's path into this work actually started in computational neuroscience, where he completed his PhD at the University of Edinburgh, studying biologically inspired neural networks in the mammalian visual system. And Philip, just a quick aside, I have a cognitive science background, so I am fascinated by that. This background shows up a lot in a lot of what Philipp builds. There's a consistent emphasis on how people actually explore and understand data and how tools can support that process. Over the years, he's helped guide HoloViz from a collection of visualization libraries into a full platform for building and sharing interactive data applications. And more recently, into the world of conversational and LLM-driven interfaces. Today, we're going to talk about that evolution and how the changing ways we interact with data are shaping the next generation of Python tools in the ecosystem. But Philipp, that's plenty out of me about you. Would you care to give us a little intro and tell us a little bit about what you're going to share with us later on today?
Absolutely. Thank you, Cameron. It's really nice to be here, first of all, and thank you for that very detailed introduction. I don't think I could have done that better. I don't think there's much you missed, to be quite honest. Yeah, I'm principal engineer here at Anaconda. I've been there about 10 years, and I kind of work on the professional services team. So we don't just build these open source tools, but we also apply them to customer problems, work on grants, etc. And yeah, that's my day job. On the side, I do contribute to open source as well. Mostly the tools I've been building, and hopefully today I'm going to kind of take you on a tour. If I thought it would be interesting to, instead of just talking about the tools individually, I wanted to take you on a tour, kind of a history of the tools and how they evolved with the changing landscape of kind of Python data analysis, Python data visualization, and so on. And then culminating in kind of this current moment of kind of weird disruption with LLM tools. I'm still making up my mind on precisely what that should look like, and I'm looking forward to discussion about that as well. Yeah.
Awesome, Philipp. Well, thank you so much for taking the time and joining us today. I'm very excited to see what you have in store for us. To help us discuss a lot of these points and the Python concepts that will come up along the way, we also are joined by our team of host panelists. That is going to be our team of Tom and Kari for today. But Tom, would you care to just take a moment to introduce yourself to our audience for those who may not know you?
Hi, I'm Tom Castle. I'm based at Bokeh National Lab, where I guess I'm a group leader at NSLS2, helping to build tools for scientists to use the synchrotron more effectively. I'm also the project lead for Matplotlib, so I'm very excited to discuss the visualization across the Python ecosystem.
Absolutely. And thank you so much, Tom, for joining. We're also joined by Kari Berry as well. Kari, would you care to just take a moment to introduce yourself to our audience?
Sure. Hi, I'm Kari Barry. I work at NSLS2 with Tom as part of the data engineering group, but there has been a growing opportunity for me to work with data visualization, including adding tiled functionality to Napari, which is a great way to graph and view data in a Pythonic way. So including webhooks and streaming data. So I'm really excited to be part of this panel and learn about the broader ecosystem, especially because I've only gotten my hands a little dirty with Seaborn and other things while I was teaching ML and training concepts to high schoolers last summer. So
fantastic, Kari. Well, thank you so much for joining us as well. Very excited to hear your thoughts on the data visualization landscape and what you're doing specifically with Napari. With all of that said, why don't we go ahead and turn things over to our guest of the hour, that is Philipp Rüdiger. So Philipp, why don't you go ahead, take the reins and share with us what you came prepared to talk about today.
Start on the HoloViz website, because lots of people probably don't know what HoloViz is, or they might have seen one of the tools or a couple of the tools. HoloViz itself is kind of a collection of libraries. We're part of NumFocus as well. And all the tools kind of have in common that they are they provide kind of a consistent way to interact with data, visualize data, and then share those analyses with users. We kind of put particular emphasis on making it easy to add interactivity from the beginning, whether that's in a notebook or somewhere else. And I'll kind of take you on a tour of these various libraries and their history and try and talk a little bit about that. And finally, I'll kind of culminate in Lumen, which is kind of the newest edition here. The logo is in fact outdated. But yeah, I'll just get started and jump straight into my little notebook, which is designed as a kind of a little tour of the various kind of individual libraries. And along the way, we'll discover kind of what they do and how they came about, and kind of how that relates to kind of some of the changing landscape in Python, particularly scientific Python. So my background, as Cameron already indicated, was in computational neuroscience. I was a PhD student. I was spending more time on coding and exploring data than I was actually writing papers and so on. And so I came into a lab with my current boss and former professor, James Bednar, who had built kind of a neurosimulator to kind of figure out how do models how does a brain kind of learn from the world and encode the information in kind of a neural network. And that was really quite a complicated thing, and I was trying to get my head around the data. And as I joined the lab, they'd already created kind of one of the first tools in HoloViz, which was Param, which really was nothing to do with visualization, but simply kind of having a declarative way to provide application state. So since then, there's been tons, right? As adders, data classes, and so on. Where Param preceded some of these. I'm not quite sure about the precise history, right? But the basic idea is that it's kind of expresses types. It perhaps leans more on kind of providing semantic typing. So basically you declare not it's an int or a float, but it's number or a range rather than a tuple. And so that's kind of been the basis of HoloViz. It provides not just the validation and kind of the declaring the intent behind things in the HoloViz ecosystem, but also adds kind of the interactivity and reactivity that we require to build a UI toolkit in Python. So that's kind of where I came into the HoloViz project before it was the HoloViz project that existed. You declare a parameterized class, you declare some parameters, and then over time we added kind of the interactive features where you can define kind of watchers. You can now pass around reactive references to things. I won't get into too much detail, but if you're interested, that's kind of where it started. As HoloViz was kind of evolving, well, no, not as HoloViz, but as the Python ecosystem was evolving, and I was trying to get a handle on kind of data sets. Particularly, I had kind of these huge grid searches across parameter spaces that I needed to visualize, and I had no idea how to do it. I printed out PDFs, which were tens of pages or hundreds of pages. Eventually, I didn't print them anymore. I just scrolled through them, but it was a nightmare. And so that's when me and another PhD colleague of mine, who's also still at Anaconda, started creating a library called HoloViews, which is kind of where HoloViz came from. And the idea was that you could simply express the parameter space and then scrub through it, right? So I could actually see, instead of kind of scrolling pages and this weird multi-dimensional space you can't really get a handle on, you would simply drag a slider and you'd see the plot update. And back then, we didn't have interactive visualization libraries in Python, right? Matplotlib did have interactivity kind of in a GUI. But you didn't, we were kind of starting with the first versions of IPython Notebook. We wanted some interactivity in there. And so I kind of cobbled together this awful HTML and JavaScript nightmare that did work and did allow me to kind of scrub through a parameter space and see the data I wanted. Usually images. Here we have a tiny little curve example, simply a sound wave, right? And soon after that, I kind of went to my first SciPy, saw a first demo of Bokeh, and I think that day I sat with the creator of Bokeh, or the co-creator of Bokeh, and still the lead maintainer, Brian Van de Veen, and he showed me kind of how to hook things up, and then we switched. We added a additional backend for HoloViews, which is Bokeh, which didn't just provide this kind of interactivity, but also provided the ability to kind of zoom and interact with the plot directly in the browser in particular. And yeah, that's really kind of the origins of HoloViz. From there, I joined Anaconda, where a lot of exciting things were happening. I got to work on a project with the UK Met Office, where we created an extension for HoloViews that would allow it to be applied to geographic data, tile sources, using Cartopy for projections. That was a lot of fun, and that still exists now, I think 10 years later. And so, yeah, it's basically simply extending the core principle of kind of declarative objects that kind of declare the intent behind what you're plotting, but providing that in addition to that, also providing the ability to define the coordinates reference system to put it on a map and then project it in various ways and add tile sources. That's kind of, yeah, that was the first kind of additional library in the HoloViz ecosystem. And right about then, I think we started considering what to name the project: PyViz, HoloViz, etc. PyViz, I think we determined was a bit presumptuous. We didn't want to kind of subsume the entire Python visualization landscape. We weren't that popular. Yeah, didn't want to do that. But at the same time, we also kind of realized this was pretty opinionated, kind of the declarative approach, and then kind of providing options on top of that. And we really do want to focus on the ergonomics of things, right? Basically, it was mostly an exploration tool, right? We were kind of dropped in a notebook. You wanted to explore some data. And from there, we created a library called hvPlot, which kind of just provided us, if you've ever used pandas and pandas.plot, it was basically taking that and making it interactive. And so all the features that were in the Python that we already had in HoloViews, and the kind of familiar API that pandas had provided, we simply kind of tried to stay within the bounds of that. Obviously, pandas.plot was designed for matplotlib as a backend initially. That's since changed. I think they have swappable backends, and we integrate with that as well. But there's obviously some differences, and so it wasn't a one-to-one mapping. But hvPlot kind of made it super simple to simply take a data set. And so today we support a whole range of libraries, not just pandas, but Xarray, polars now as well, and allow users to kind of explore data sets interactively using kind of just a single line of code or a couple lines of code. And if I don't know, if I were to, for example, I'll say group by, I should probably check the column name, but manufacturer, we could then combine kind of the two types of interactivity very easily. And now I can kind of get a widget that lets me switch between different manufacturers, right? And so we're kind of coming full circle with the idea of not just having this interactivity, but also exploring parameter spaces, etc., super easily in just a couple lines of code. At the time at Anaconda, they were also building some libraries to really deal with large data sets. So two libraries that came out of kind of that initial effort. One, I was there, were Numba and Dask. Numba kind of lets you write really fast kernels of kind of the hot paths, something that runs all the time. And so building on that was built a library called Datashader. Actually, it was created in Anaconda before I joined, or roughly when I joined, but kind of was subsumed into the HoloViz ecosystem with the other tools. And so we integrated it in such a way that it would kind of integrate neatly with hvPlot, with our other tools. And so the idea being, if your data is too large to fit in a browser, right, you can't, with a matplotlib plot, of course, you can just plot data. It might take a little bit longer, but in the end, it just dumps all the data points into a plot, and you get a PNG, maybe an SVG, which might also cause you issues. But here we just have 72,000, so it's not crazy. But let's say we had tens of thousands, hundreds of thousands, millions, or even billions of data points. The idea is that we still wanted to interactively work with those. And so the idea behind Datashader was to basically take that, rasterize the data, and then provide shading, the ability to shade the data, which means kind of providing, applying color transforms to really highlight differences, such as kind of histogram equalization, which really shows you geographic patterns really nicely and other patterns really nicely. And we combine that also with the ability to provide link selections. And so now you could kind of take data sets with tens of millions or hundreds of millions of data points, shade them. You can kind of zoom. Let me zoom in here, so we can actually see. As we zoom in, right, you can see it re-rasterizes it, and so now we can interact with much larger data sets interactively, still in the browser. And so with the link selection, I can now also apply selection across this and have a linked histogram that shows me kind of in the subregion that I selected what is the subset. So that's kind of where our visualization tools kind of stabilized, matured. And at the same time, though, we were kind of in a notebook. People weren't clear on how to share the results, right? You could share the notebook with the code cells, and maybe you can even hide the code cells. But you might want to share it with someone who doesn't care about the code or doesn't even want to see kind of all the code cells and is not familiar with the interface. And right about that time, we created a library called Panel, which basically was the idea was you could simply declare the widgets. They would, you could then build a whole application in the notebook or outside the notebook, and then effectively turn the notebook from kind of a static thing that you could export into an interactive thing that you could deploy as an application. And that's the idea behind Panel. Around the same time, Plotly Dash came out, which is also a really nice tool for the same purpose, and created kind of this new category of Python things for building what's now called data applications. Streamlit, I think, became the most successful out of the bunch. But yeah, effectively allowed us to take a simple, a plot, add some widgets, and then add a little nice template around it. And then you could kind of share and build an application. There's tons of examples out there now. And over the years, kind of this is really where most of our focus went, right? We really knuckled down on Panel, built what I think is a pretty compelling thing, which kind of sits in a weird space in the ecosystem, in that it's for novice users, it's perhaps a little unwieldy and complex because the API service is fairly large. But I think it's really powerful for a lot of different use cases that perhaps Streamlit doesn't quite cover because it has a different execution model, right? But yeah, that's kind of where most of the last, I think, 5, 6, 7 years of my life has gone, building Panel and applying it to different use cases. Nowadays, initially we kind of built just on the bokeh widgets and stuff. More recently, we just released Panel Material UI, which kind of finally brings some more modern looking components to Panel. And really kind of allowed, I think the AnyWidget folks have really shown a really nice way to build new components that are reusable and more easy to build. And based on that pattern, we kind of adopted our own mechanism for building extensions that didn't require kind of JavaScript framework, compiling things, etc. And now there's kind of a whole series of Panel extensions built around this. Yeah, that's kind of the history as of last year, I think. I don't want to kind of dive too much into details. I do want to leave a good amount of time for discussion. But as LLMs came out, we'd actually been already building a different tool, something called Lumen. Lumen was effectively meant to be a declarative way to specify data pipelines and dashboards or entire applications. Effectively, there's a very common pattern, right? You've got some data, you want to transform it in various ways. Some parameters control those transformations. And so you build a data pipeline in that way. And then you simply feed it into some kind of view. And if you do all of that in a declarative way, then you can simply have a YAML specification, or well, at least a serializable specification of what your application should be. And that's kind of that was the idea behind Lumen. We realized nobody wants to actually write the YAML or these serializable specs. But in fact, LLMs came around just as we were like, okay, maybe Lumen isn't the way. And it turns out that LLMs are pretty good at generating, or at least have become pretty good at generating well-defined specifications that they can output. So that was kind of where the idea behind Lumen came from. Lumen is now a chat with data framework, which there's quite a lot of out there. I'll give you a quick demo of that shortly. But the idea being that you can connect it to your database, to your local data sets, to your kind of data lake sitting in the cloud, ask questions about your data. And then the most important part, because it is built on Panel, because it is built on open source, so all of these tools are, of course, open source, that you can extend it. You can build custom analyses, etc. That simply build on top of this. But yeah, look, enough talking about that, and I'll quickly show you a demo in action. So yeah, this is kind of the default Lumen UI. This is, I think, kind of the combination of what you can build with Panel now over the years. But here I've kind of preloaded it with a few data sets, some earthquakes, data set of New York taxi trips, and wind turbines. And now I might ask a question, right, which is, can you select earthquakes above 8.0 in magnitude and plot them on a map? Again, agentic AI stuff happening in the background. Effectively, it makes a plan, right? It breaks it down and assigns the tasks to various agents, and then effectively generates specifications, where SQL is one of the specifications, right? Pretty simple. It simply writes a SQL statement, in this case, filtering the data, and then plots that on a map. So in this case, it's using DecGL as a specification, but the idea being it can also output big lights, and also HoloViews, etc. So that's kind of the idea behind it. I can then also say, actually, can you plot that as 3D bars scaled by magnitude? So the important part here is that basically, well, I guess that didn't work. Demo effect. But the kind of core principle here is that you should always be able to inspect what it's doing, right? You always see the specification as part of the output. At all points, you can export it to various formats, right? You can save the map to various formats and then share it. And then finally, a vision that's perhaps not fully complete yet is that you can then kind of assemble this output that you've just generated by chatting with it. You can persist that, generate reports from it. And then finally, also, a piece that's not done yet is you can then take these components and lay them out on a grid and share them. Yeah, that's kind of one way we're trying to see what we can do with LLMs. I think an open source tool to do that is, I think, a good thing. Precisely how to apply how LLMs are changing the landscape, still hard for me to kind of envision precisely, and what changes they will have on kind of data app tools. If you can now kind of generate a whole React app with a simple prompt, does anyone really need Python tools for this anymore? I do think my opinion is that yes. There's lots of legacy code out there. You kind of the slop issue is a is a big one. But yeah, the other way that I think we're trying to adapt to this change in the ecosystem is to provide HoloViz MCP. This is actually one of our kind of longest and most prolific contributors, Mark Skov-Madsen, who created HoloViz MCP, which kind of helps LLMs understand HoloViz tools a little bit better. I'm still making up my mind on LLMs, but with the landscape changing, I think we're at least exploring what this could look like. That's, I think, it for now. So I'm excited to discuss with the team, other folks.
Fantastic. Well, thank you so much, Philip. This has been very interesting because not only one, do I love the history of open source tools and how they've changed, but I am also curious to see the direction that you're intending to go. And I think the LLM one is very, very interesting. With that said, why don't we go ahead and open up for some discussion? So our host panelists, if you have any points to bring up or any questions to ask Philip, please go right ahead. And if you're in our audience, please go ahead and submit your questions via the Q&A so that we can read them aloud and have them discussed. But Tom, I saw you came off mute pretty quickly there. Did you have...
Oh, no, that was just getting ready so I could
Getting ready.
I
I have a question. And I'm curious, you kind of alluded to this a little bit with the transparency that you showed in the LLM workflow. It generates the SQL query and then possibly even generates some, at least the Lumen YAML specification so you can reproduce the charts. I'm curious, is there any way to like kind of export an entire conversation and all of the iterations on kind of a data flow to app?
That's a good question. That is part of the vision. Right now, effectively everything's serializable, right? So you, in theory, we could simply dump out kind of the individual chat messages. We could dump out the individual components that were rendered. We just haven't hooked it up yet. But yes, the idea is basically that you kind of store common conversations or common, what we call them explorations, I guess, in Lumen, and you simply perhaps have common ones that you simply within your team or within your organization, you just share them across the team. Here's the most common things, and you can then tweak it and say, well, actually, I wanted to change this and this and this about it. But yeah, that you can kind of persist and serialize them and then return to them.
Yeah, that's really cool, especially since the input format there is just YAML for at least for the Lumen end of things. Just like any standard text-based version control would work there, which is really cool because then you can see how the dashboard changes over time from its source code produced via conversation.
That's the vision, not quite there.
Yep. Any other thoughts from our panelists? Tom?
Just replay the same conversation multiple times. Just you provide the same responses and let the LLM do whatever it says on its side and see how often it it actually does the same thing.
Yeah, that's a good point. For simple queries, I think we see a lot of consistency, but yeah, and the more you kind of get out there and ask more complicated things that require multi-step things, I mean, it's like a random walk. But I think, yeah, the inspectability, I think, is the core part that makes it useful. I think a lot of tools just spit out a thing and then you have no idea, right?
And so speaking of queries and specifically complicated ones, like I noticed that predominantly the demo was sort of a declarative construction of a visualization, but I feel like the average consumer who might pick this up and might not be a data scientist in the same way that we are, or someone from corporate who's trying to do projections and things like that, they might also ask to visualize things that become, are supposed to draw specific conclusions. And I mean, we often use AI for predication. We use, we've gone into PyTorch and made things that can do pretty accurate predictions of all sorts of stuff like weather. So, but we also know that LLMs hallucinate a lot with that stuff. Have you ever seen, asked it the kind of question where it could do that or overfit or underfit in the way that it plots the data or produces results?
I think in terms of kind of the SQL and the actual visualization, usually it's okay, but as soon as you ask it to like make speculations about a big part of it is, of course, like also generate some texts to describe what you've seen or make a prediction. Yes, it does drift. I think a core part of what should in the system, you're totally correct. Like you can't let anyone loose on it, and that's what we kind of found. It's like we tried it out on our marketing team at Anaconda, and they asked questions in a construction that the LM just didn't understand and spit out nonsense. I think the core part here is that Lumen really, in a fully set up environment, it should basically define a bunch of pre-canned analyses or functions, and then all it does is call that function so that you get a kind of consistent, well-defined specification of what the result you want is. And so really then it becomes more of a router to figure out, okay, what is the user asking for? And so call this or call that. And I think in that construction, it's much more reliable and makes much more sense.
Is the idea that it generates code rather than the answer directly, such that you can always kind of look at the code and see what's going on, but it won't create data elements that don't exist out of thin air?
Correct. I mean, it always has to effectively use data as the input. It currently, in the default mode, right, we kind of have always envisioned this as a thing that you deploy. And so a lot of the stuff around kind of sandboxing code execution didn't really exist when we started building it. So we never let it generate code because it seemed scary to us. I think if you're running it locally, letting it write code, I guess, for some users will be fine. But generally, kind of, we've always tried to keep the scope of the thing and what it's doing as narrow as possible, right? So that it always has to start with some data set, some predefined table that's already there, or a table that is already generated. Then it applies some transforms to that, and then it spits out the visualizations based on that, and it doesn't have the kind of the freeform thing of, I don't know, I'm just going to write some code that generates synthetic data and then plots that instead.
And it can't do evil things like use very special X scales or Y scales so that to make your
In theory, it can, if you ask it to. I think.
Not to the Claude bot level of, oh, it has access to my entire machine and several other APIs. It's just the data that you have in the SQL or Parquet. Yeah.
Very
That's
broad question when advocating for these kind of tools. So if you were to take a very pessimistic view of this, you might complain that any automated code generator that generates, say, SQL is going to give you a wrong answer because it will put an equal sign where it means or it should say an is not null. And it'll be very subtle and you won't capture it because it'll still be correct SQL, but it'll give you wrong results. But at the same time, a human being is going to do the same thing, right? So my question is it enough to say that the LLM gives you the same quality of output as a human being, thus we should use it? Or should we set the bar higher for the LLM than we set for the human being?
I think that's a very good question. I don't know what the right answer is. I'd say, I mean, we also always run a validation agent at the end to say, okay, is this output nonsense? Which fine, that agent can also make mistakes. So
and a
in
human
the
being
end,
could just as readily make exactly the same mistakes, right?
yes.
LGTM, James, LGTM.
Yeah. I do think people probably, particularly people who are not data scientists, will potentially put more trust in, well, I'm not sure that's true either, right? I mean, if a data scientist on your team says, here's the result, you probably trust that more than the LLM because everyone's now been talking about how much LLMs hallucinate. So, yeah, I don't know.
Is it better or worse that the LLM can be wrong at scale, but the human being has maybe a limitation on how much scale they can be wrong at?
I think there's also an aspect of if you're talking to a human, they can tell you how confident they are, whereas it seems LLMs are always very confident.
Yes.
And then you tell them you type into the machine that you think they're wrong, and then they autocomplete to be very confident that they were wrong before and they're right now.
To be fair, I'm very confident about code that I write that ends up being very wrong.
Yeah, I think yeah, my perspective here is, and I've been building this tool for a while, and obviously, yeah, you'd expect that to be like, "Oh, it's great, everything's perfect." I think we're still learning. One of the things, right? I mean, certainly when we started building this, the LLMs were much worse, and they are now much better. And if that continues, then maybe, yeah, it comes to the point that yes, it is actually consistently more reliable than a human. I don't know if that's true, but um, it's a new world, and we're discovering, I guess. And I think,
One thing that I noticed that some of the newer models give you more of, but the older models didn't, was the guidance when you're asking the wrong question. And this is something with SQL, like a very common question that I think some models still give you wrong is if you ask, here's some data, tell me the max value, it won't handle ties. How do you design the tool to do what a human being would do, which is to say, hold on a second, you're asking the wrong question. What you really mean is this. Here's the answer to the question you should have been asking.
for us, we'd solve that with kind of the agents that validates things at the end. Effectively, it's just doesn't just check the answer, but also checks the question, right? Um, Again, it's similarly prone to failure, but I think as long as you kind of put enough guardrails and enough validation at the end, I think you can be reasonably confident it's doing a good job. And then really we do want to push, certainly in this tool, that it calls actual code that's been validated by a human that's put the system in place for your team or for your organization. But as a general question, yeah, we're all learning.
I'm curious for the analytical or the data layer. Is it just SQL that the Lumen will write for you, or is there other like pandas or polars or something that would also?
So yeah, we've kind of come late to this. I basically was against code generation entirely in Lumen from very early on, and then we decided, okay, actually, if you're working locally, writing some pandas data transforms is fine. And so we do have the ability to effectively launch it and say, okay, code generation is fine. You can invoke the code transform agent and write some pandas or polars to transform the data. And so that's possible. I've so far been pretty happy with SQL. Certainly, I think there's fewer subtle mistakes it'll make. Again, my confidence level, which is ironic, is I think fairly medium to high, I guess. It's not a lot of it is like I feel like the LLM does better in this case. Certainly validation is kind of the biggest problem here, right? It's like, yes, we write validation tests for Lumen, and we see it consistent, but then we're also kind of you're optimizing for those validation tests in the end, because they run all the time, and so you make sure that the prompts are engineered in such a way that the validation tests pass, and yeah, it's difficult.
Yeah.
I'm curious.
There's also
Go
the
ahead, Corey.
bias.
Oh, I'll let Tom say what he's going to say first because it just sounds like
There's the bias that I find the LLMs are bad at things I'm good at and very good at things I'm bad at.
Yeah, that's sort of what I wanted to touch on a little bit is the heuristic aspect of this, since you have a neuroscience background and sort of the way, visualizations aren't something that's implicit. They're also cultural. They draw on the rich history of Anthropocene, the way that we as human beings have determined, oh, red means bad, green is good in financial prospects, but it's the opposite for thermal imaging. So with stuff like that, and I mean, my background specifically before this in university was in sonification, and that's a very interesting way to interact with data because you wind up having to rediscover how people think about things and also what their cultural background is. And so I think, I worked on a sonification algorithm at the relativistic heavy ion collider here at BNL, and the noise that it would make would determine if the scintillators were in alignment. And so the only noises that we could determine that people consistently would identify as good or bad is if it was organic or metallic, meaning that there's a lot of saw or spike or square waves and things that are maligned, and a very sort of like sinusoidal, like almost a splattering noise for things that aren't. So when you're developing this, like one thing that I noticed during your demo was that it made the points for those earthquakes just fine, but they were really obnoxiously tiny points. They're just kind of there. There's certain things that these AIs and LLMs might not understand about the cultural aspect of visualization. And so what are you doing to sort of counter that, to say, oh, if I'm looking at a thermal imaging set, then blue in this case, since it's in Kelvin and is really, really hot, is the hot gradient, like how are we determining?
Right. Yeah, the goal really is kind of, if you were to stand up a system for your team, right, you do have to encode your assumptions. You kind of have to encode, yeah, here are the expectations of my field, here are the expectations of the viewers, and then you have to effectively prompt engineer that into the system. I think out of the box, yeah, it'll do fine at the things that it sees the most. So financial charts, perhaps maps to a certain extent. We also have that feedback loop where kind of we have it self-criticize, so it exports the chart and then feeds it back into the LLM and then tries to refine it from there. That's part of it. But yeah, without kind of tweaking the assumption of your audience, you're never going to get the right thing, I think. So for this very simple demo, right, it's basically I'm simply invoking Lumen in the most simple way, where no customization whatsoever. And in the final system, I think, yeah, you have to encode these custom analyses that you do for all the time, and that you have the very specific assumptions about the color map that it should use, and yeah, whatever else is common in the field, right? Without that.
And does it also tend to follow stylistic like accessibility guides? Because when we're talking about things that appear in the web browser, like there's ways that things should be labeled so that they're accessible to more people, or just even the way that tooltips, get rendered. I'm curious to see, as a person like who's having AI generate these things, does it include those more often than not?
I think it's much better, particularly if you include that in your prompt. I think our prompts for certainly the Vega agent do tell it to follow accessibility guidelines. And it is pretty decent about doing that, particularly kind of picking color maps that are perceptually uniform, picking colors that are, I think it is more aware of accessibility guidelines than I probably am, even though I've been trying to, well, on the sidelines working on making Bokeh more accessible. And yeah.
I was just about to ask Philip, is Lumen the plotting portion? Is that built on top of Bokeh, or is it built on top of HoloViews to have swappable backends?
It currently, again, a big part of it was that we wanted kind of output specifications, and so Vega Lite was, I think, the best specification that we thought LLMs could generate, and so we did a lot of stuff with that. I do now have kind of a prototype for a spec for HoloViz plots. I mean, effectively, hvPlot is not difficult, right? It's simply data and then all the arguments, and that's fine. That works pretty well. But if you want kind of that full pipeline of HoloViz features where you apply this, you apply data shading, and then you do the link selection thing and stuff, that's something we still need to work on right now. Basically, Vega Lite and DeckGL are the main ones we support well.
Awesome. And then James, you had a question?
I have a fairly complex two-part question if we have time for it. The first part is for Tom. Matplotlib is an absolutely amazing tool that has been used as part of the visualization for some of the most meaningful scientific results. It's also a tool that's used to create visualizations that don't mean anything, don't say anything, that sit on dashboards that nobody looks at. Has it ever given you any pause that matplotlib is the mechanism by which enormous amounts of human time, effort, and just life are wasted? Or is that outside of the scope of, as a tool developer, you'd say, I just create the tool, I don't care how it's used? You don't know how much I
I
have been asked to create visualizations. Cameron and I have been asked to create visualizations that nobody looks at.
But were you paid to create those visualizations?
Yes.
So I feel as a tool developer, I have done my job. I provided you a tool by which you could uh, do your job. And I think at the end of the day, that's as a tool developer, you focus on enabling people to do their jobs. And if that job is uh, ill-advised, that's I consider that out of my scope.
When Philip, you're creating a tool like Lumen, I could see that this could, in a very similar sense, be used to give somebody the ability to easily query their data, but not really do anything but waste their time going in circles, asking questions that don't mean anything, getting answers. In the development of Lumen, do you have any particular design considerations of, let's make sure that this isn't just telling us things which you could easily just eyeball from the data? Let's make sure this tool is actually used to solve real people's real questions.
I think that's really the problem with a lot of these tools, right? It's just you point it at some data and then say, generate some insights, and then it'll create a bunch of obvious insights. Fine. The I keep iterating this, but I think the only way it will really be useful is if you kind of predefine, here's the insights people actually care about, and here's what they look at all the time, and here's what they use to get their job done, and then focus on those and have the LLM simply effectively call those up.
So push back on that a little bit though. I mean, think there's that data set that it's like all have the same mean standard deviation and are all wildly different shapes, including one of which is a T-Rex.
Dinosaurs doesn't.
Right. Even the like just put this on the screen so you see the obvious thing you would have eyeballed from it, making that as smooth of a process as possible, and making more people able to just like at least glance at the raw data once to say like, oh yes, that should be a line and it's a line. Great, next. That seems like it from a like making sure these tools get used for the greatest impact. That still seems useful, even if like
I agree.
that line plot is not going to be on a dashboard that someone's going to look at like every 5 seconds because it's always a line. But the ability for someone to see like, yes, that's a line, and the one time it's not, they can.
Right. And I think for us, that was also the kind of one of the motivating factors for Datashader, right? You just throw everything at it instead of kind of, okay, I'm going to look at the first 5,000 rows and be like, what does that look like? And it's totally by a sample, right? You just throw it all at the thing, and it shows you patterns, and then you can investigate deeper, right? That's, I think, a big part of it. And if the tool can do that easily for someone who doesn't write code, then I think that's a good thing. But yes, it will also be used to generate a bunch of junk, I'm sure.
So maybe we should just adjust our prejudices for what's considered useful or meaningful work, and where that bar really is for an average user.
That's fair.
I mean, just think my own process when I'm making figures to present to someone. I make a tremendous number of figures that pop up on my computer. I say, no, that's trash, close, and try again. Right? There's a lot of iteration, and again, making that iteration more fluid for someone who doesn't know the libraries as well, or doesn't have time to or want to learn them, has great value, because now currently what they're doing is they get a plot out of something and say, fine, I'll accept it and move on. Or just never make plots and just like look at the summary statistics and draw conclusions from that.
That brings up an interesting point, and I think we just have time for one more question here. But Philip, you mentioned a couple of times that there's this validation kind of end for the AI or for the LLM where you feed the plot back into itself. Is there a way for a user to interact with that validation portion and say like, what improvements would you make to this chart or things like that?
Not currently. We haven't explored that too deeply, unfortunately. I think it's a great idea, and I think that's really, I think like all LLMs should have a loop at the end that's effectively look back at it and critically evaluate, right? Because But I wonder if that just goes into the loop of pleasing itself then and says, "Oh yeah, actually I was wrong, totally wrong. So let me fix this."
Yeah. It's how it
Um,
builds up so much self-confidence.
yes, indeed. Um, so yeah, I think there's a lot of exploration to do on that front. Simply doing more validation, um, showing it the output, having it do that work.
Mhm.
Yeah, perhaps at James's point that we're wasting less human time making these plots that will just be iterated over and shifting that to be the AI's time, which is both positive and negative. It certainly makes shareholder line go up in terms of token consumptions.
I
But
think
the
that
humans still have to look at the plots. The LM can help us make them, but a human's got to look at them.
You got to look at the plots. Yeah.
that's been the big LLM issue facing everyone everywhere. It's for all the output that it generates, somebody's got to look at it. But this has been amazing. I think it's a cool transition, especially factoring the history of kind of Panel as a tool. Going from Panel was at the prime of when low code tools was really at its height or its peak, and Panel was this really easy way where you could use one programming language. If you really need to do some advanced, tap into JavaScript as well, but one programming language to build kind of a full stack data application. And now we're even going further down this to decrease the barrier of accessibility, to let more people work with their data, manipulate it, and visualize it to come to some conclusion. And I think that's a really, really promising endeavor because, I mean, for all of these data visualization libraries we have in Python, relatively, the barrier to entry is kind of high. A lot of them are somewhat low-level visualization tools. If you use raw Bokeh or Plotly, right, without the express layer, matplotlib even, there's a lot of API to learn there. And so being able to have something be flexible, yet not require a lot of learning on the back end there to create a visualization, I think is really promising. So Philip, thank you so much for coming on and joining us to share this tool with us. I think Lumen has a very bright future ahead of it.
Thank you so much, Cameron, and the rest of the panel.
Thank
Excellent.
you.
All right, everyone. We'll go ahead and adjourn for today. I want to thank our panelists as well as our audience for joining us. And if you're curious, I would encourage you to keep an eye on our website. That's meetup.doepy.org, because next month we'll be joined by Daniela Procida, who's most well known for creating documentation diataxis. So that'll be a session you don't want to miss out on. Thank you again so much, Philip, for joining, and I hope to see you all around. Thanks, everyone.